Okay, I decided to explain it like this because it just makes more sense and it's probably more interesting. Okay, so starting off with corporeal. Um, in fact, let me just do every single maths book that you will use. I'm gonna have to use this. Okay, so if we start off with maths, um, then the old spec was really weird. Wait, they're the same. Well, you don't do decisions. Okay, anyways, year one, you know, nothing changed. Year two, really simple, nothing changes. Year one of stats and mechanics, that's it. Simple. Um, so all of this you could do just GCSE knowledge. Chapter two, this is where you start learning content. Although all of this is really easy. Your calculator does it for you. Something that's difficult. Probably where you have something like this. Then you just need to guess essentially, and if your guess works, it works. Then this is just graphs. That's it. Same as chapter 4. Why can't I? Yep. Chapter 4, still graphs. This is really easy, trust me. It's literally just a straight line and you guess it above or below, and then it's done. Which is why it's only like 3 pages. That's not a joke. It's literally 3 pages. Probability is what we're currently on. Really easy again. And they do get harder though. So it won't always be like the 3 circle thing. You get this, or you can have split. So you can have 2 circles and then 1 circle over here somewhere, which is always nice. Statistical distributions is pain. Can't deny that one. Your calculator does most of it, but it still take a while. All of this is meh. You can do all of this. Then on to mechanics. Yeah, mechanics is just GCSE. Definitions, you can just guess. Like I know you know what a particle is, or what a rod is, or lamina is. At least I'm guessing. Literally just a 2D plane. Gravity, obviously. This is all the same as regular physics. Constant acceleration. This is just physics. Like exactly the same as physics. This is also exactly the same as physics. Just vectors. What else is there? What is new? Variable acceleration is the only thing that I'd be like, okay, this is the only interesting part about this. Especially this. Although I hate this. Other than that, doesn't really change. Hello. Just going through textbooks. Why? I'm not doing anything. I haven't done anything wrong. What are you doing? I'm just reviewing textbooks. But why? No. Well, yes, but like, there's a mic in front of me. What did you expect? I haven't even clicked on anything. The only other thing open is like this. Cinema. I'm trying to record this. Excuse me. I'm sorry. Sorry. Can you also? That just sounds sad. Yeah. Anyways, back to reviewing stuff. Cinema. Okay. So you have. I can tell you're sitting right there. You haven't moved. Cinema. No, you haven't. Okay. So if we do blah 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 blah. That was awkward. This you will hate. This you will. Revise for this early. This. Oh yeah. By the way, chapters 1 to 3 are all of stats in year 2. That's really nice. Everything else just mechanics. This is This is just really easy mechanics. Like I could do this right now. Find the coefficient of it's so easy. Like it's just physics. This is the only difficult thing, I guess. Slide. Oh my perfect. It's just okay. Okay. Moving on. Oh, I should probably reset that. I don't want to be 100% on the book that I haven't actually 100%ed. This should be higher. Anyways, um, yeah, for regular maths, it's really calm. For further maths, though, oh, I'm gonna want this. Anyways, um, why is that broken? Anyways, for further maths, complex numbers, this is really, really easy. I guess the most difficult thing you could possibly see in here is no, these are still all really easy. Yeah, these are easy. Argon diagrams, these are basically just trig. Like you'll recognize this kind of thing. Um, and this. It's exactly the same as trig. Um, then you just have formulas. Loci is also really easy. I guess the most difficult thing is have a weird thing like this. This is also really difficult, but this specifically, understanding it at first, and then being able to write other notation really quickly is annoying. Um, and that it's easy. Sigma, I don't want to spoil this for you. Thumbs up stuff. It looks really ugly sometimes, but it's really cool. This turns out to be really long, but it's also really easy if you know what you're doing. Other than that, Sigma doesn't change. These are polynomials. If you can skip it, if you can't skip it mentally because it's ugly, it's just formulas and substitution. There's nothing interesting about it. I guess if you have like ax squared plus bx plus c multiplied by ax squared plus bx, you can find like the roots of the equation without polynomial division or whatever. Skip steps. Yeah, it's just dead sometimes though. Like it's just meh. No one likes it. Volumes of revolutions, my favorite one, excluding proof by induction. It literally just involves you finding a strip, then rotating it around an axis, such, um, to get a volume. It's the thing I like about it that you actually use it. Like it's not something that you just learn for the fun of it for maths. You will eventually use this in real life if you go into a job relating to like engineering. I don't know, random science stuff. This is useful. Um, like even the random stuff about modeling. There's a specific one that's like a pen. This just looks weird. Of a golf. No, no. There's a pen one that I really like to see. It looked like this, anyways. You guessed what the pen barrel shape would be like and blah blah blah. Then you just modeled it, and then it's fun. And then you just integrate. Some of them can be long matrices. Hmm. They're okay, you know. Like they're really easy. It's just finding the inverse of a 3 by 3 matrix. It's just long. Like you know, it's bad when maths has to just talk in your words, phrases. Um, 5 steps. Each step can take up to a minute and a half minimum. So this isn't like each question will be like 6 marks. Like let me find, yeah, 6 marks, 6 marks, 6 marks, 4 marks. Not nice. Oh, okay, okay, actually. Um, this is just a really easy concept. This same um simultaneous equations. You can solve it really easy. You'll learn a trick where you could just plug in stuff. What else is there? Solving real world problems and linear transformations. Just putting things from one place to the other. This is just GCSE. If you look hard enough, you won't get the notation at first, but it really is GCSE, and then you get a matrix and you just multiply it. You can imagine it like vectors. Anyways, I guess the most difficult thing to initially comprehend. If you haven't done GCSE rig well enough, this will just look ugly. But it makes sense. Like if you're rotating something around this below the matrix. Anyways, all of this is calm. This is disgusting. So essentially what it is, you take a, so let's say you stretch something, then you also translated it, and you only have the original position and the final position. You need to be able to tell what happened. So obviously you can just map it out and see what happened, but you only have one transformation. So you're gonna have to guess if it rotated or if it translated and do a bunch of other stuff to it. Which is cool some of the times, but sometimes you just don't want to do that. Proof by induction is my favorite. For a lot of reasons. It's just really fun. Once again, sigma is everywhere, which is why you see it in biology so much. Anyways, yeah, it's really easy. Like once you get the trick down, like it took me like a week to understand. Well, not understand. A week, okay, it took me like a day understand and then try, and it worked for this question, I think. I couldn't do it for the rest because I didn't understand how to factor anything out well enough. So for example, this question where you have whoops, this one was easier. No, this one was worse. This one is just r multiplied by r factorial. Then you have to prove that it's equal to n plus 1 factorial minus r. Really easy. At the same time, like it's, I feel like this would be 6 marks ish. This does not deserve to be anywhere near 6 marks. It's really easy. You can just tell. If you do it enough, you'll be like, oh yeah, he just skipped the proof step. He just skipped everything. This one, they skipped the base, so they didn't attempt it for n equals 1, so it doesn't work. This is long, but it's cool. They used it in IMO Grand Challenge question, which I might send, but I won't bother. It's very useful. The rest of this, matrices I have not tested actually. So it looks the same. You just factor out so and so, and then you get an answer. Yeah, the most basic thing. It just requires a lot of practice. Vectors, they're okay. I don't care enough about them to do extra work. Anyways, to book two. Book two is where you want to start revising after every lesson. I can tell you that for a fact because they open up with one of the hardest things: complex numbers with exponential form of okay. Yeah, this isn't fun. Okay. Yeah, this part is just long. Like it's not fun. It's really long. This is just year one, but slightly worse. Ugh. Okay. Quick identities. This is all normal. Some series. Series comes early for some reason, although there are less chapters, which is good. Hence, proved by method of differences equals. Ew. That's long. Yeah, that's very long. Proof by methods and calc. Ooh, this is okay. This is fun. This is actually fun. Like this is useful. I can't really. I don't want to spoil anything. This is. I can't explain this now. I don't have time for that. What's the best thing I can explain? Find the region shaded R integration, and then you just do some extra steps. Polar coordinates you will do in a while. Hyperbolic functions you will also learn to discuss, although they are quite interesting. It's just year two stuff for pure. Hyperbolic functions again, it's really long. Modeling with the, yeah, this is one of the best things. It's literally just like real world problems and you apply it. Blah 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 blah. Really fun content. do mechanics. And um, mechanics is also really short. They just you don't need much. Is physics immediately after moments, regional moments. Cinema. What? What? I'm trying to. It's fine. It's just like okay. I'm just gonna go back. So this exactly. If I have the physics text, you'll see what I mean. Like the physics textbook. Yep. Ah. Okay. So if you take a look, vectors, scalars, and vectors, adding them. Okay, that was regular maths, like mechanics maths. Then forces doesn't change. This exact diagram is also in maths. Okay, then we go to moments. Moments don't change either. Nothing changes. Okay, even moments. Hey, math. This is generic. You're not allowed to actually do that for some reason. Um, where does it get gravity? Uniform acceleration. We don't do variable. Blah 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 blah. Projectile motion. Exactly the same as mechanics. Year one. Newton's laws of motion. Same. I believe the same. Momentum and impulse. Blah, 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 momentum. Okay. Does it say same? Conservation. Yep. Identical. It's identical. They don't change anything. Like its word is slightly differently, I guess, but like this is still exactly the same. If you look hard enough, I could do these questions. This one, I saw this before. I don't know where, but I saw it. Where on earth? It's somewhere. I'm thinking. Oh, okay. I saw it before somewhere there. Really easy. The rest of this is pretty basic. Why is that here? This is still just physics, specifically physics, because Hooke's law is just materials. Elastic in one dimension. This is still physics. This is just further kinematic. Okay, that's cool. Didn't know it would crash on me. Yeah, so this is further kinematics. That's two dimensions saying nothing has changed at all. What do you want? Thank you. Okay, that's cool. Thank you, Kaspersky. Year two, circular motion. This is all generic physics again. Well, I say generic. It's slightly. This time it's more mathsy. So yeah, something like this you wouldn't do in physics. Because it has too much maths. Apparently, they don't let you do it. This is that's boring. Eh. Centrism. Actually, I did have a question about this. Like, how do you calculate the center of mass of an object that's really large and you can't hang from like a bob thingy, whatever they call it? This is it. I'm actually gonna. I need to remind myself to learn this in my free time. I don't know when, but I need to. This is more generic kinematics. In fact, let me check. Yeah, it's just Suvat, but slightly harder. Dynamics, same. Okay. Nothing has changed. Can go for this note at least. Then if we go on to more further maths books, so you said further pure um explain um it's mm, okay vectors kind of, yep, doesn't just a lot of graphs dead. This is wild. I don't know why this is here. um there's more matrices for some reason. This is actually just matrices. This is still matrices. More matrices, vectors and matrices, identical again. This is useless now. This is the longest chapter one. What on earth? Oh, okay, that's cool, I guess. Conic, you're gonna want a graphical calculator for this part. Um, for a specific reason, which I would have to show you, but I can't. It just skips a lot of this. Like it does everything. Um, this is this is what I used to find the volume of my math teacher's mug. Bravo to me, anyways. But just I used 10 centimeters, so it was like 10. Then it was 1 over x plus 5 minus 5. Minus 5 plus 5, I'll remember. Then you just integrate between where it touches the y-axis, because I added plus 5 minus 5, so it does now touch the y-axis. And then you have 2 bounds here. So it's a square. Take away this bottom region, which is this. You can multiply it by 4. You can get the cross section bottom. Then you can integrate again to get like a wave function thing. That's really cool. When I say wave function, it's a function. Anyways, in this, yes, no, still generic. Conic sections exactly the same, just with more cosec stuff. Inequalities. I don't know why this. Okay, I'm not doing. I'm glad I'm not doing this. Too many functions. Okay, the T formula. When T equals tan. Oh, this is actually useful. Okay. This idea too. Okay, that's what the guy in step was basically saying. I needed this formula for a question on a proof with 2 weird angles. I'm gonna need this as well, because why not? Probably just take a picture of the page. Anyways, this. Don't spoil this, even though you're not gonna do it. Taylor Swift. This is amazing. Okay, this is the best thing. You get the time, do this like in your free time, because it looks cool. It looks long, but it looks so cool. Everything here, it just makes me go like, ooh. Not actually, but like, you get the point. The ugliest question they have. They don't have any. Oh, oh no, that's questions in calculus is generic. Okay. When I say it's generic, I mean it's just calculus. It's just calculus with extra steps. Don't worry. Number. This is genuinely useful. Like it's actually like it's a thing that you use as well. It's like volumes of revolutions again. And proof by induction. This you will actually use. More integration, different. Yeah. Okay. Yeah. So it's just the thing you'll learn with further pure. It's I want to learn this. Okay. It's a lot less experimentation and it's more just memorize as much as possible and apply it as fast as possible. So I don't really know how to describe it. Number theory. Number theory is something I checked on accident. It's really weird. Something I need to learn anyways. Um, Division algorithm. Yeah, it's cool though. Like it's actually useful. Like it's the one thing I would just copy and paste and just use in my exam. Anyways, um, division. Yeah, yeah, yeah. Further pure is just theorems and memorization. Like it's that's it. It doesn't change. Hurry up. Okay, I won't go over decision, but you get the point. Further hasn't changed in the past like 10 years at all. So don't worry about that.